Gas evolution reactions. We mentioned this at the beginning, the kindergarten volcano. Gas evolution evolves a gas. Some of these form a gaseous product directly. Sulfuric acid and lithium sulfide will form hydrogen sulfide, which is a gas, and lithium sulfate. And the only way you would know that's a gas is you just have to memorize that. Other reactions are going to form an intermediate product that decomposes into a gas. So if we have hydrogen chloride and sodium hydrogen carbonate or sodium bicarbonate reacting, we're going to get H2CO3, which is carbonic acid, and sodium chloride. Well, it turns out carbonic acid is not stable. It decomposes. It loses a water molecule, and then what's left is carbon dioxide, which is a gas. So this intermediate decomposes and forms the gas. So if you have a reaction where you get H2S as one of the products, you just need to remember that it's a gas. That's a gas evolution reaction. If you have a reaction that gives you one of these three as a product, carbonic acid, sulfurous acid, or ammonium hydroxide, you need to know that these are unstable and they will decompose and form a gas. So let's just look at those real quick. If I take H2O out of this, I get CO2. You see what happens if I get rid of two H's and one of the O's? I've got CO2. Look at this guy, H3SO3. If I get rid of two of the hydrogens and one oxygen, I am left with SO2. There's a pattern here that can help you remember what to do with these guys. They're losing H2O. NH4OH. I get rid of two hydrogens, this one and one of those. That leaves me three here. And I get rid of the oxygen, and I've got NH3. So that's what these guys do. So if you get one of these as a product, then you need to do another arrow and put these guys. So the examples here, let's look at this one. 2HCl plus K2SO3. When I swap partners, I end up with KCl, so that guy's over here, and then in the middle I end up with H2SO3. That's this guy. H2SO3 reacts further to form SO2 and H2O. So that's where we get those guys. So when you're writing these equations, do the skeleton, reactants and products. You're looking at swapping partners. And then this is the part you just have to remember. H2CO3, H2SO3, and H4OH are going to decompose into water and what's left of them, respectively. And so write that out and then balance the equation. So here's an example. Write a molecular equation for the gas evolution reaction that occurs when you mix aqueous hydrobromic acid and aqueous potassium sulfite. Well, what's the formula for hydrobromic acid? Hydrobromic, is that binary or oxyacid? Hydro. It's binary. So a binary acid is one that starts with the prefix hydro, and that means it's just hydrogen and bromine. So this is HBr, and then potassium sulfite. Well, let's do the ions here. We're going to need those. Potassium is K+, and sulfite is what? SO3. It's the light version, 2-. So that's K2SO3, and that's also aqueous. And then we're going to swap partners. So I'm going to get K plus with Br minus. I'm going to get H plus with SO3 2 minus. So I get KBr. Is that soluble or insoluble? Soluble. Potassium compounds are always soluble. And then this guy, I need 2 of these. I'm going to get H2SO3. And then your brain should say, hey, wait a minute. That's one of those guys that forms a gas. Here's another clue. It's a gas evolution reaction they told you in the question. This guy. So let's erase this stuff down here. So this guy decomposes to form water, and see, we lost the 2 H's and we lost one of those. What's left? SO2. Let's balance this before we copy it out nicely. Let's see, there's 2 potassiums, so I'm going to need 2 over here. And now I've got 2 bromines, so I'm going to need a 2 over here. And that 2 hydrogens will take care of these 2 hydrogens. I've got 3 oxygens, and I've got 2 plus 1, 3 oxygens. So now I did all my scribbling, I can write it out neatly. 2HBr aqueous plus K2SO3 aqueous forms 2KBr aqueous plus, what's the state of water? Liquid. Unless it tells you otherwise, assume room temperature. And SO2 is the gas. Any questions? Yes?
How can we carry the 2?
Which 2?
Okay, like in the second equation, how instead of it being K2Br, it's like KBr, and then it's H2SO3 instead of just HSO3. Like, why do those?
Oh, why is this KBr instead of K2?
Yeah.
Okay, that's a good question. This is K2Br over here because of the charges on the ions. This is K plus and SO3, 2 minus. And so in order for this to be a neutral compound, there needs to be 2 potassiums for every one of these. Over here, I've got K plus and Br minus. Br only has a -1 charge. And so the neutral compound is going to be 1-to-1 ratio. So these subscripts do not get carried over unless you're dealing with a polyatomic ion. Does that make sense? Okay. Any other questions?